Pipe Up is an event that is held by SPE ITS SC to increase the college students' knowledge and skills regarding oil and gas industry.
Okay, good afternoon everyone. Thank you Mbak Anissa. Kalau eksplorasi lanjutan disebutnya sumur apa? Sumur-sumur eksplorasi lanjutan itu. Jadi kita masukin acid ke dalam sumur. Jadi juga teman-teman sukses terus, teman-teman ITS tetap rajin belajar, rajin organisasi, tetap kompak.
To create a new project or a new model, you can click here. That's what you want to do. Then we have tools, material balance using for estimate the original oil in place in the reservoir, analyze the drive mechanism, and detect if the reservoir affecting by water influx. A reservoir allocation, this used when a well is producing from multiple layers and you want to know how much each layer has contributed to the total production. Monte Carlo simulation, it's used to perform statistical evaluation of reserves. Decline curve analysis, this method used to extrapolate into the future for forecasting. 1D model, this used water flooding scenarios for predicting breakthrough times and saturations. Okay, so we will start with material balance. This is the main window. Here is the reservoir tank. Material balance have limitation and assumptions. So this is assumption and limitation of material balance equation. The reservoir is assumed to be as a tank. So here is the total bore volume of the reservoir. The second point is the reservoir is assumed to be homogeneous, means they have no uniform reservoir properties. For example, the value of porosity will be at the same in the all reservoir, and the thickness, if you want to use a reservoir thickness, it will be homogeneous, and other properties, it will be homogeneous. The same in all places in the reservoir. The reservoir temperature and pressure are uniformly distributed. Also, the reservoir temperature will be assumed will be constant. Here we have some options. Add a tank, mean if you want to add a new reservoir, add well. You can add well here if you want to connect it with your reservoir. This is the connection option, and move when you want to move the reservoir at any place. Okay, so this is our options here. We'll use them from the left to the right. First of all, we select options. Here the system options, tools for selecting the type of the reservoir fluid, oil, gas, general. We have an oil reservoir, so select the oil. If you have a gas reservoir, you can select this one. Tank model, single tank or multiple tank. This means if the reservoir it's single, no connection with other reservoir, select tank. If you have many tanks or many reservoirs connected together, you can select multiple tanks. For example, you can here add another tank and another one, and then connect between them. So we will remove this one and this one because we have only one reservoir. We will change it to single tank. Here's BVT model, simple BVT or variable. If you have many BVT data, you can select variable and change them. But we have one BVT. production history by tank or by well. Here is in this option, if the reservoir is producing from the tank, means cumulative of all wells, we have to select by tank, or if we add a wells, we can select enter the production by wells. Here we will select by the tank. Okay, this is another information. You can add your company name and the name of the field, the location, platform, and the names. Here you can add comments. Add stamp means you can course. Okay, that's the date of today. Okay, done. The next step is we want to enter the BVT data. Fluid properties, select this option. Here's the main BVT data, basic BVT from your Excel sheet. Okay, this value formation GUR. Okay, BVT data, we have a sheet for BVT data. Formation GUR, this number of formation GUR, it will be above the bubble point value, means here's the RS, it's 490 standard cubic feet per stock tank barrel. So we will enter this value. Okay, the oil gravity of the reservoir. Oil gravity can be entered here is the value of oil gravity 34.9 ABI. You will enter it in the reservoir. Okay. The gas gravity 0.95. Water salinity 200,000. We need water salinity. It's very important value to use it for the correlation to calculate the water compressibility. If we don't have the value of water compressibility, we can enter the water salinity to estimate by correlations. Mole percent H2S, the percentage of H2S if we have in the reservoir, but the reservoir will be 0. Also the percentage of CO2 0, and the nitrogen is 0. Okay, this is the main parameters of the BVT. It will be used for the correlation of if we don't have the BVT data. We will talk about the BVT correlations later. Okay, after entering this data, we will go to the table here. There's many options. Now we will use the table to enter the table of the BVT data. First of all, the temperature of our reservoir, it will be a constant value. It's here, 238 Fahrenheit degree. Okay. We want always to check our units. Here's the degree Fahrenheit. If it's Celsius, we want to change it. You can change it from this units. Look to the temperature. This is the example. If you have a Celsius and the degree, maybe you can change your value to the Fahrenheit or change the units from here. This is the temperature. You can change it to the degree for input and also to output. Okay, after doing this, you can go. This is changing, but we'll keep it the same as in the Excel file. Temperature, sorry, Fahrenheit, and this Fahrenheit. Okay. After entering this data, we'll go to the table. Here is our temperature and the bubble point pressure. We want to enter the bubble point pressure from the BVT. The bubble point pressure 2535 psi. Now we want to enter the table for the pressure and RS and beta oil. Before doing anything, we have to check the units. The pressure will be in the PSIA. If we can change it from here, but in the data it's in the PSIA. It's okay. Just we need to check it to be going right. This is our units. Okay. Now you want to enter the BVT data from the Excel sheet. This is the hard point because you cannot copy these data like this to the MBAL. Look, if you want to use the copy, it cannot be copied. So you want to change each value individually, and this is the hard thing, BVT table. So and be careful to enter the pressure and the RS and the oil formation volume factor with each value. So you will start with number 1 here, focus on this point, and starting by enter each point for the pressure and so I will do something here. To be easier to enter this data. Be careful during enter this points. So now click on the table. It will be here. This is the best way. I always use it to enter these data to don't have any mistakes. Okay, the first point is 5000. Focus here is the gas oil ratio. The first number is RS GOR. It's 490 standard cubic feet per stock tank barrel. Oil formation volume factor 1.328. You want to enter every point. Sorry. Now you can start enter these data carefully. And be patient to enter every step. This is the pressure. What's the value of the oil formation volume factor and RS. to doing everything is there. If you doing something wrong here, the software will not tell you no, this is wrong. It will take the value and estimate on it, so your result will be wrong. Okay. I will start by entering all of these. This is the point above bubble point. Pressure. It will be the same. We explained the PVT data in the previous Excel sheet videos, so you can go and understand more deeper about the PVT data. Now we will complete below the bubble point. Okay. This is the last point here. Okay. Okay, we finished all the PVT data as a table. You can see in the plot here the MBAL software generate the plots. Here is the gas oil ratio versus pressure. This is our points. Maybe if you enter something wrong with your table, it will appear here. As it's the typical of the gas oil ratio, the trend will be the straight line until the bubble point. Then when the pressure dropped below the bubble point, the gas oil ratio will be decreased. Can move to the next variable, oil formation volume factor versus pressure. Here's the typical above bubble point. Also, beta oil will be expand, means the expansion of the oil volume. Then below the bubble point, after the gas liberated from the oil, it will be shrinking. Okay, the next, these 2 points. This is what we entered into the reservoir until now. If you have oil viscosity, you can enter it, but now we don't need any viscosity because the material balance equation didn't use the oil viscosity, but we can estimate it by correlation. Will we layer on that later? And if we have a gas oil formation volume factor, we can enter it here, and gas viscosity and water formation volume factor. These are most important data we need: pressure and gas oil ratio and oil formation volume factor. Please, here's something wrong. Bubble point pressure. Okay. After entering this, okay, we can click on done. and here done. Now we entered the BVT data, the basic and the table. After entering the BVT data, we can go to the input to enter other data. Here is well, if you have and if you add a well here by this button, you can enter any well data from here, but now it's closed because we don't have any well data, but we have tank reservoir data. Select tank data, tank input data. This is all the data of the reservoir to build reservoir modeling, starting with the tank parameter, means the reservoir, the main reservoir data. Here's the type tank, it's oil. If you have the name of the reservoir, okay. X reservoir. You need to enter the temperature at the same value as which entered into the BVT, because it's assumed to be constant. The initial reservoir pressure, the value of the initial reservoir pressure, it will be in the basic reservoir data. Here is the value of the initial reservoir pressure, 4,714 psi. Okay, this is the initial reservoir pressure. The value of the porosity, it's between 0.12 and 0.14. So here is the range of the porosity, but it's okay to enter the value one of them. As I said before, all the porosity changed in the reservoir from place to another, so it will not be constant, but here is the material balance. Assume everything will be homogeneous. That's one of the assumptions of material balance. So we want to enter the one of them. Okay. This value can be changed later. Connate water saturation. Also, we have this value. It's between. Okay, it's between 0.20 to 0.21. Here's the value of water compressibility. If you don't have any water compressibility, you can, the material balance, the MBAL software have many correlation to estimate the water compressibility. So if you don't have any value, you can use correlation. But we have the value here of water compressibility, 3.4. Okay, 1 psi. Initial gas cap, our reservoir is above bubble point. As we saw in our analysis, the reservoir data, the reservoir pressure is above bubble point, so no initial gas cap, it will be 0. The original oil place estimated in this place. One of the objectives of material balance is to estimate the original oil place. So here the MBAL need the value of the original oil place estimation. Here we can use the value or the first guess for our model. It will be from the volumetric equation. We talk about the volumetric equation and how can we estimate the original oil place. So we use that in our Excel sheet, the assignment. Here's the parameter using the volumetric equation, the area and the thickness and the porosity and initial water saturation. We estimated that by using volumetric equation, 674 million stock tank barrel. So we will start with this value. It will be the first guess. Then the simulation will estimate the original in place, and we will compare the values. Here the 674 psi, and in the simulation model it was 691 million stock tank barrel. The difference between these two values is about 2.5%. So will we enter this point to the software? The starting of the production date. When here's the date, and this is the format of the date, day, then month, then year. So the starting of production will be in the production history. You can see the production history here. Okay, sorry. Here is the first date when the production started. We will enter it here. Look to the format. You want to be at the same in the MBAL. Date. Sorry. Okay. After enter the basic parameter reservoir, you can click on done. Now we can see our reservoir, its color is changed from the white to green. That means all the bore volume filled with the oil and the original release estimated at the same value we entered, 674 million stock tank barrel. This is the first point, and it will be changed after using the history matching and trying to get a matching between the pressure of the actual pressure and the simulation. After entering all of this, we have to save our work. So go to the file, save as, select the place you want to save the file in. So I will go to the online course here and a new folder. MBAL. Okay. Yeah, I make a mistake. Here's the link. Yeah, the file name is not valid because I used some, okay, because I used some ones lecture. Now I can click, okay, it saved it. Always after entering any section, you want to click on the save to save your work. If you lose your work, you will lose everything and you will start again from the first point.